section 6.4, which is how to use inverse functions. Okay, if you recall, prior to vacation, we talked on that last Friday a little bit about what inverse functions were, an introduction into them. And inverse relation interchanges the input and output values of the original relation. So if you remember, we talked in terms of having a set of input and going into some set of output. For a function, we go from the input to the output. For its inverse, we are going the backwards direction. We're going to undo whatever the function did to our input. So in a function, the input is our domain and the output is our range, whereas for an input inverse, the output becomes our domain, and what initially was our input is now the range. And if we take a look at an example, I believe before vacation we looked at a parabola and we saw what happened. Let's take a look at the function f of x equals 4x plus 2. What's the graph of 4x plus 2 going to look like? It doesn't have an x squared, so it's not a parabola. What's its form? mx plus b, it's going to be a... You're going to see how bashful you are. Why was mx plus b? What's that?
Slope-intercept.
Slope-intercept form, it's a graph of a
straight line.
So this is a graph of a line. So if we make a chart of xy values, if we do it for, we're going to do a few more points than usual for just graphing a line so that we can see what's happening with the inverse. So if I plug -2 in, what are we going to get?
-6.
We'll get -8 plus 2, which is -6. How about if I plug in -1? It'd be -4 plus 2 or -2? Oh, 0. Easy one, right? 2? 1? You like these better now that we're getting positive? 6. And 2? 10. Okay, so if we make ourselves a set of axes, and if we just plot the points like we would anytime we're graphing a line, hopefully, as you're getting this set, your line may look a little bit like my line. inverse. What do we do to get the inverse? We interchange the x and y's. So we're going to take our ordered pairs that we had before and we're going to switch the order. The y's become the x's become the y's. So are you following all right how we reverse the order of our chart? So then if we go to plot our new points, -6, -2, green is getting temperamental, -2, -1, oops, -2, -1, 2, 0, 6, 1, and 10, 2. The green line that I'm drawing, which would be the inverse of our original function, and we usually denote the inverse by f to the -1 of x. Now, my inverse, is the original line a function? How do we tell if a graph is a function? It has to pass the vertical line test. So is the white one a function? Yes, it passes the vertical line test. How about the green one? Is that a function? Does it pass the vertical line test? So, both the function and its inverse, which is the green one, are functions because they pass the vertical line test. Now, sometimes it's going to be useful, rather than have to make the chart and plot the points, to come up with an equation for the inverse. So, to find the inverse algebraically, all you have to do is interchange x and y, and then solve for y. So, for example, our original problem that we were working on, number 1, f of x equals 4x plus 2. When we see f of x, that's really what? F of x is just another name for y. So this is really y equals 4x plus 2. So if we change the variables, what's it going to become? Instead of y equals 4x plus 2, it'll become, instead of y, we're going to put x, and instead of x, we're going to put